Hello, everyone, from wherever you may be. Welcome to the GSE UK Conference 2020. Some of you may know me already, but for those who don't, my name is Dave Austin, and I'm Senior Technical Consultant with BMC Mainframe Services, primarily working on ZVM and Linux on Z, amongst other things. If you have any questions, if you could submit them via the chat, I'll be monitoring that chat screen, and I'll pass the questions on to Kurt as they come in. I'll now hand over to your presenter, Kurt Aker of Synomony, who will take you through transforming zTPF to Linux. Over to you, Kurt.
Very good, David. Thank you. And welcome, everybody. Thanks for joining this virtual event. I'm pretty excited to be able to speak to you all today. If there's not a lot of questions, we will be quick and end a little bit early. Obviously, we're kind of all used to having a room full of people, right? And the interactions in that room is kind of how I balance a lot of my material. So again, feel free to ask questions throughout. Dave will actually interrupt me and answer them. That way I don't have to try and keep track of the chat while we move forward. As mentioned, my name's Kurt Aker. I'm with Synomony Associates. I've had a little bit of trouble pronouncing that Latin term, but I'm getting better and better at it as we move on. So again, the QR code's at the bottom, and at the end, we do have the questionnaires, and would appreciate everybody taking the time to answer those. So really today, what I'm going to talk about, right, is TPF and shopping traffic on reservation systems, how our company was able to really help a customer, right, move not completely off the platform, but really hybrid clouds. Why Linux on Z was used, which Dave mentioned is his area of interest as well. And then really that last bullet there for the agenda is more of a thank you and questions chart, right, to open up the room. What I found interesting last night, I received an email from the IBM Systems Media group chat that really concentrated around the recent TPF user group and some of the, I hate to say it, but kind of horror stories around getting off the mainframe, the cost, and some of the viability of what we're really looking at doing and trying to help customers do, right? And that's balance a hybrid cloud and being able to move workload over to Linux while maintaining your existing systems in a cost-effective fashion. So again, that article will be on the charts that'll be uploaded. I'll do that when we get done today. So they're available for download and you can check it out. It's a really interesting article. I thought it was very well written. And of course, the timing is fantastic. So really understanding the impacts of reservation systems, right? And travel. This is a point where I'd ask folks in the room, right, if they raise their hands, if they remember working with a travel agent. And for some of us, right, it kind of dates us, I think. But for the younger folks, you might not know what that is. Early on, right, travel agencies are still a really, really big thing. They still work on a really, really regular basis. But what they do is they collect the customer's interest. Where do you want to go? How do you want to get there? What are your things that you really enjoy doing, right? The types of activities. And then they go out from their databases and their contacts and really build an agenda that includes only a few typical choices, right? They'd know the areas, they'd know your interest, so they cater to your needs. And what we call book ratios, right? Book to look ratios of 3 to 1 were common. They give you 3 choices, you'd pick one, and that was about it. And then along came the internet. And with that, right, the real-time tools that were developed isn't just a reservation system statement, right? But it's how we work today, right? So a lot of people actually say, well, what's the real cost of shopping? Well, the real cost of shopping comes down to the fact that if you don't have that information available to the public, they're not going to book your rooms. We're all pretty savvy these days in being able to use the tools that are available to us on our smartphones and on our computers. And a lot of the algorithms that have been created from companies like Expedia and Kayak, and now there's internal travel agencies that different customers use. They collect all this information on a regular basis and make it available for all the people that are trying to make those bookings. So if you're looking for a hotel, right, you search in an area and it shows you from Google all the different hotels that are available from Google anyway, and the rates. If you don't have that available again, people are going to look elsewhere. Trains, planes, all the same kind of thing. Busing systems, these are all reservation systems that require that real-time ability to cater to the individual customer needs. And are you looking for cost? Are you looking for location? People play around with these things, and it really accelerates the demand on your system. But at the same time, right, if it's not there, you don't get the business. So you really have to provide that data. And unfortunately, it costs the same to process that data as it does to make the reservation. If you don't have the availability with the rooms and the cost, and again, right, the first point I made, the availability, is that room really available? Because the last thing you want to do is sell somebody a room or a ticket that then when you go to actually pay for it isn't available. Bait and switch doesn't work that much. It just gets people upset, and they'll move on to your competitors that will have real prices and will allow those customers to book whatever it is they're looking for. So it's not just internet, right? And the ability of these crawlers to actually go through and get this information and provide it back to you in a real-time fashion. There's a lot more to the impacts of those back-end systems that we saw with one of the latest customers that we worked, right? It's more than really CPU. How long it takes for the IO transaction rates, right? What's the increase, the amount of IO to gather all the information around a customer's portfolio? Again, it's not just customer A wants to go to location B, right? It's customer A wants these certain things when they get there, and they expect X amount of their travel. And you got to put that information together in a portfolio, right? And grab it from all the different databases that you've collected this information from, put it together in a single format and present it back. That's increased memory footprints dramatically for these transactions. The cost, this really goes back more to CPU, right, is greater. You have more information that you're processing, you're putting more messages through the systems. The lifetime of them grows dramatically. You're no longer looking at a single system, right? A single database with a simple query. You've got multiple databases with multiple queries. You've got multiple other interfaces and companies that you're integrating with to pull information down to create this package that looks good. And then there's also multiple angles of expansion, right? Again, I kind of talked about the amount and the types of data that's being requested, but the microservices and the APIs that people are using today, understanding how they actually affect your back-end systems can become a little bit of a little daunting, quite honestly. It's something that you really need to pay attention to as you build these services, because again, your back-end systems get busier and busier. You have to scale to accommodate that busyness. And if you're not scaling properly or watching how those microservices are using your systems, you're basically wasting a lot of cycles to serve customers that are really looking for items of interest. And then, of course, you've got mergers and acquisitions, right? A lot of people are buying up companies. Don't invent something new if you can buy it and use it. And then there's more and more security every day, right? There's another breach somewhere, another type of interface that you got to be careful with. And the firewall and intrusion protection services, these are all hops within your network. More and more with APIs, more and more with different clouds as you expand into hybrid clouds and start to bring in more services from other companies, right? These are all hops that your networking traffic has to make in order to complete that full picture of everything that you're looking for. So why Node.js and MongoDB, right? In our case, for this customer, TPF was the answer, right? TPF was a reservation system that was being used, and we needed to understand the traffic flows coming into that TPF environment and what we could do to try and manage that data at real time without really interfering, right, with the customer traffic, with what the customers were looking for. We started with shopping traffic. That's the biggest pain point for most reservation systems. It's not just a hotel industry where I came from recently. When I worked from IBM, I worked with train companies, I worked with airline companies. They all have this same problem. You have to make sure that you're running at the speeds that you can run at. In this case, you'll see on a slide coming up, we knew we had to get to 6,500 transactions per second. We were able to achieve 9,000 transactions running 4 shopping engines is what we called them. And basically we had that system running on one system, KEK 1, and then we took a load generator and ran it on a secondary KEK. We did that to try and simulate traffic coming from the outside, right? This way, all the calls weren't just done inside the same mainframe and blur the lines, right, of reality. We absolutely had to make sure that the calls coming from the outside could be handled through the system. And as you'll see in a little bit, we found that the OSA card was really our limitation at this point, not the systems and the Linux guests themselves. But here we can give you a little bit of a interface of what we actually ran, right? We had 3 virtual CPUs that ran on the shopping engines. The 4 load generator guests really cranked up the message volumes. And then the different MongoDB servers, MongoDB requires you to actually run an odd number of servers. In our case, we were using 1 as primary and the other 2 were backup. So the backups in these cases really did nothing. They just sit there in case the primary fails. It allows for a failover. And each test cycle had 100,000 requests and just ran in loops. That can be a little bit misconceiving in a test, right? Because you do get a lot of cache data, but we did turn things like mini disk cache off so that we were hoping to hit the disk all the time. In this case, the customer actually has all solid state systems drives. So the response times from that is extraordinarily fast, really, really quick. This next chart's a little bit dated. It's from a Z13, but it was really meant to show how well Node.js actually does run on the platform and take advantage of the instruction sets. Unfortunately, these tests were run later on, or this code is running on a Z15. We just don't have the access to be able to run the test again. To show the difference between the Z13 and the Z15, that's something on our to-do list, but it's like so many fun to-do lists, it gets pushed out, in favor of real customer work over interest in our own metrics and how well these things actually work. So why Linux on Z? This is a chart that really gets a lot of attention. I've been presenting this for almost 3 years now. And literally this chart right here seems to be the eye opener. It shouldn't be to a lot of people on these types of calls, right, that are familiar with mainframes, that are familiar with Linux on mainframes. We all kind of understand the differences, right, in architecture between x86 and mainframes. The IO piece of it being, I think, really, really critical when it comes to working with a database. How fast can you access that data? How fast can you manipulate it? How fast can you respond with information back to your end customers? Again, I mentioned that our required load was 6,500 responses per second. This chart does not mean by any means that x86 clouds are bad. It's a matter of understanding your limitations and what you need to make a working environment. So in our case, we knew that running this on a mainframe, running this with Linux on System Z, a single database could handle the workload. Just like our test case showed a couple slides earlier, right? We absolutely knew that we could handle all the workload on a single database and then leave the other 2 for high availability. This saves money for the customer. MongoDB charges by memory footprints. If you actually put this on an x86 server and you needed to handle the required volume rates, you would need 3 servers in production to handle the workload. So now instead of having 1 server handling the workload, you've got 3 of them, and then you need some more for high availability. So you can quickly see how fast that memory footprint just grows and grows and grows. And we haven't even talked about dev test and quality assurance environments, but you really want to make sure all those are in play as well. So again, right, it's not just the single service that you have to look at. It's holistically the whole environment and what really makes sense. Now, the flip side of this, trying to move this piece of the puzzle out to a public cloud wouldn't work. The realities of that is the speed of light would get in your way of the transactions. So again, the 6,500 responses per second are based on that information getting into the system and a reply coming right back out. If you start moving things out to a cloud, you've got to understand the speed of light, right, that's interfaced with that. And now are you going to be able to make those numbers? Well, you might be, but it's going to be delayed, right? So I don't want to say you can't do it, but you have to understand that delay factor. And then what are those impacts of that delayed response compared to an end customer request on the rest of the systems that sit behind it? Most of them aren't very fault tolerant, when they're expecting sub-microsecond responses. And all of a sudden you've introduced a lot of latency due to, again, right, the speed of light and being able to get out to other services and then get back into your systems. We do see an awful lot though, in the background of doing this, of taking data that's actually sitting in these environments and moving them to other databases, right, for other types of manipulation, business intelligence, building better queries, financial reporting, information along those types of things. Again, this process worked really well because we have two databases that are sitting pretty idle. They're just getting updated from the primary. But that doesn't stop the end customers, right, from the other lines of business from actually using those databases and reading information out of them, be it to put into another database or just manipulate it directly using some of the tools that the people are using. So again, it was a lot of fun actually working on this particular chart and the studies behind it. The data that represents here is, I think, a critical understanding point, right, of why you would want to use Linux on a mainframe, why this hybrid cloud that you keep hearing about does make a lot of sense. How can you integrate it with best of breed services while maintaining the workloads that you need to work and maintain the systems that are actually required to keep the businesses up and running while you're transforming and modernizing them? And by that term, I mean, really, right, how do you keep up with the end user's demand for fast speeds, quality content, quickly and accurately, right? So again, my view is those systems of record, those mainframes that are used today, do those types of things extraordinarily well. How you front end that information becomes a much different story and an interesting progress. And I think someplace that we'll see a lot more growth around the whole hybrid cloud model. Now, of course, it'll be interesting to see how much IBM puts into that and really makes these systems become much more available within their clouds or other providers' clouds, right, potentially, in order to create this hybrid environment that's not in your own physical data center. Moving Z systems, I think, into modern, quote unquote, cloud data centers, I think will become a critical component to allow customers to actually move out of the data center business and into a fully cloud-like environment while still having the controls and the speeds and abilities that things like mainframes do have to offer. Now, the other key point to this chart, right, I think, is that when we got to a certain threshold, 64 test threads, the mainframe didn't lose any data. We actually processed 100% of the information. It was just the amount of time it took to process it wasn't acceptable to us, right? We knew where that cutoff point was, but that cutoff point was well above the boundaries that we needed to be. And again, what we found out from working with the IBM lab in Poughkeepsie, the TPF team there, is that our limitation was the 1 gig OSA card. We absolutely flooded it. That card couldn't handle any more. But what that card did do and did provide, right, was the ability to buffer all those messages coming in. And then by buffering it, was able to process them when the CPU and everything else, right, when the throughput from that networking card could get the calls in, to process it and move it out. On the x86 side, it was pretty much 100% loss of data. There was nothing there that was of value anymore. Again, this was a single case. It was meant to be looked at as, what's our limitation? Where's our limitations at? And how can we get past them? What makes the most sense for the business? So in this case, overrunning x86, right, it was very clear that running a single MongoDB instance could handle that load and work very, very well in this environment. And I'm going way too fast. So with that, I'm going to ask for questions before going on to the questionnaire and the questionnaire for this session. Does anybody have any questions? Well, I really appreciate your time. I'm sorry I went so quick, but I'll give you guys back about a half hour of your time today. So don't forget to fill out your session feedback. Again, there's a QR code. I will have this information loaded out onto the website today, later on this afternoon. And then there's a charity that you can also donate to. The share conferences have always been big on the communities and local communities, and I think they got a really good charity here. So please feel free to visit it. Again, if there's any questions, please feel free to ask them. Dave?
Kurt, I thought I saw a similar presentation last year that Neil did, and he showed some charts of how the environment was built.
Yeah, I didn't see that material.
Okay. So,
but
it's a shame because it would have actually put a little bit more
context in
glossiness
there, yeah.
on it. Yeah.
Yeah, I mean, really, ultimately, right? I guess I could have shown those charts too. I've got access to them still. I built them. Some of the original ones.
there is a comment from Alan Playford. So the main problem appears to be the capacity of the OSA card. Were there any alternatives or comparisons on faster, bigger OSA cards? I would have thought that maybe link aggregation would have helped as well.
Link aggregation was something that was being looked into, and upgrading to 10 gig OSA cards was actually on the customer's plan. The 1 gig cards were actually loaner cards on the new system, but the networking team had issues upgrading the backplane to 10 gigs. So the system's still on a 1 gig environment today. Unfortunately, due to COVID, right, the demand on those systems has gone way, way down. So that 6,500 transactions per second mark probably won't be realized for at least a couple more years now.
Okay.
But yeah, no, great point and great question. And then link aggregation was absolutely one thing that we were looking at, right? Today, there's that customer still using a traditional OSA connection. They're not using both their OSA cards. They've got one set up for failover. Again, link aggregation, right, will allow both those OSA cards to be in play. So you drop the demand down by half unless you had an OSA failure, in which case then you'd have to be really careful that you can handle the entire load with a single card.
Yeah, I think there's also a limit on the amount of share you can do with 10 gig cards as well, which might.
Yeah, they only have one port, right? But they do have a lot greater capacity, where the 1 gig cards came with 2 ports. So it allowed you a little bit more flexibility there.
Yeah, I was thinking about sharing between other instances like
ZOS and stuff.
Yeah.
Yeah.
So there are implications. I think they're addressing some of those now with some of the new stuff coming out.
I would agree. Yeah, no, that's clearly something that they're looking at, right? Because there is a lot of sharing, right? And this environment shares. Now, the TPF environment doesn't share with Linux, but Linux does share with ZOS in this case.
Yeah.
Yeah, and I should have put some of those charts, right, that really showed the how the host system worked, right? Because it's not just a shopping engine. There was actually a maintenance engine that takes the data from TPF and loads it into MongoDB. And then those shopping engines, what they actually do, and it's kind of a quick high-level story, right? But they're now looking at all the shopping traffic that's coming into that reservation system. And they're basically saying, is this a valid message? Because what we found, right, is that the reservation system itself has to get rid of messages that aren't good, right? Which is really overhead to that reservation system and the general purpose processors that it runs on. By being able to have all that traffic flow through Linux, we can now sit there and monitor it and say, are these good for that database? If not, they can be rejected right from the beginning and never get to the general purpose processors. They're processed all at the IFL with Linux and then sent back.
Yeah, I think Alan just, I think you just answered the question that Alan was going to do. I was going to ask how the TPF data got transferred into the MongoDB database, but I think you just answered that one.
Yeah, we actually wrote or helped write we called it a maintenance engine, right? And it really just loads the data. It's not automated today. That's another piece that they're still working on, but it's manually loaded when they want to load more data. And really a lot of that is the business side of that house really wanted to make sure they had close controls over everything that was happening to make sure that it was really working like we said it would work.
Okay, just as a matter of interest, what distribution did you go for on that implementation?
Are you talking about the Linux?
Yeah.
It's Red Hat. That's a Red
Okay.
Hat shop. Yeah, so everything's Red Hat there.
Okay.
And that's true from the distributed side as well as the mainframe side.
Okay. Okay, well, thank you. Thank you, Kurt. That was great. If there's no more questions from anyone, I think we can end the meeting.
All right. Hey, thank you very much. Have a great day. Enjoy the rest of the conference.
Cheers. Bye.
Cheers.